Hello everyone, in today's video we'll be going through recurring decimals. So we'll be going through three different sessions, one being what is a recurring decimal, second being how to turn from a recurring decimal into a fraction, and finally how to turn a fraction into a recurring decimal. So let's have a look into what a recurring decimal is. So a recurring decimal is written like this, as shown here as 0.39. And these dots are called recurring, so you read it as 0.39 recurring. So what this means is it's being repeated again and again and again and again, and pretty much forever. It does not stop. So whichever digits have that dot on the top means it's being repeated again and again and again. So if you had something like 0.3, it's being repeated 0.3333, and once again forever. So that's all a recurring decimal is. So that's all you need to know in terms of a recurring decimal. Now what we will do is we will actually go into the applied side of this topic. So in a GCSE question, you're more likely to get a question like this. In a GCSE exam, you're more likely to get a question like this, which asks you to prove that the recurring decimal 0.39 recurring is equal to 13 over 33. So I'm going to go through a structured manner in solving this question. There's of course other methods, so feel free to check other methods out, but I'll be focusing on one method which is most likely to give you full marks. Yep. So let's have a go. First of all, you will sign the recurring decimal they give you into x. So x is equal to 0.39 recurring. So then you will count the recurring decimal places. So in here, after the decimal point, you have 2 decimal places, right? So what you will do is you will times by 100 on both ends. And this would give you 100x is equal to 39.39 recurring. So how does this work? So just as a conceptual side of things, we have 0.39 recurring, which is 0.39393939, which goes on forever. So if I were to multiply by 100, the place value, the decimal point will move twice to the right. That will give me 39.393939 dot dot dot. It's still going to repeat forever, which means it's still recurring. Hence, I got the 39.39 recurring. Hope that made sense. So now what we will do is we will use these two equations you created and try to find x. So I'm just going to write on this. I'm just going to separate this section so it's more clear for you guys. So you have 100x is equal to 39.39 recurring, and then we have x is equal to 0.39 recurring, and you simply subtract these two equations together. You get 100x minus x, which will give you 99x, and that's equal to 39.39 recurring minus 0.39 recurring, means the recurrings cancel out and you're left with just 39. So the reason we times by 100 is because we can just cancel out the recurring. So we want to get rid of the recurring and end with a normal number, which is in this case 39. So now you will solve it normally and you will divide by 99 on both sides, and you will get x is equal to 39 over 99. Am I done with this question? No, because they want it in 13 over 33. So I would simply simplify it. So divide by 3 on both numerator and denominator. That leaves me with 13 over 33. And if you remember, in the very beginning, you defined x to be 0.39 recurring, which means now you figured out x to be 13 over 33. So now what you just did is x is equal to 0.39 recurring, which is equal to 13 over 33. Hence, you have proved what they asked you to prove. I hope that makes sense. but let's just summarize the whole steps one more. So you don't really need this side in a real exam. I just did that for you guys to understand the concept behind what happens when you multiply by the 100 to the recurring decimal. So in your real test, what I will expect you to have is assign the recurring decimal they give you to x, multiply by 100 if it has 2 decimal places. If it has 1, you multiply by 10. If it has 3 decimal places, you multiply by 1,000. Yeah. So it's about the number of decimal places. So in here, I counted 2, so I times by 100, and I expect you to show this. Then the next part is I expect you to show the subtraction. Then you rearranged it and you simplified it. So that would be the main 5 steps you have to show in an exam, and you're good to go. So that's pretty much conversion of recurring decimal into fraction. So now let's move on to fraction to recurring decimal. So let's move ahead to here. So in here we have 3/11 to a decimal. So they want you to convert 3/11 fraction to a decimal. So the most straightforward but kind of a long method is long division. So what I'll do is I'll do 3 divided by 11. So 11 doesn't go into 3, so 0. Not 0, 11 going to 30 2 times, that gives me 22. Subtract, I get 8. 11 doesn't go into 8, so I add a 0. 11 going to 87 times, so I get 77. Subtract, I get 3 and 0. 11 goes into 32 times, so that's 22. Once again, I get 8, 0, that's 7, 77 minus, and I get a 3, add a 0. So I kind of think you guys got the concept here. It's pretty much being repeated 27, 27, 27, 27 forever. That's what the repetition going, because you kind of see the pattern of getting the 30 and 80, 30 and 80 again and again. So what happens is you just convert 3/11 into the recurring decimal of 0.27. So I will kind of advise you guys to do it 1, 2, 3, 4 times, because you see the pattern if the number is being repeated or not. So in the 5th time, if it's the same number, go ahead and write it as just a recurring decimal. So that's the method to turn a fraction into a recurring decimal, pretty much just long division. So what you have been learning all the way from primary school is the method for fraction to decimal. So hope that helps. So that's pretty much for the recurring decimal topic. I will link this worksheet below. So try to attempt all these questions, and if you have any doubts, let me know. I can always make a video of working through all of these questions if that would be helpful to you. Perfect. So that's it for today. Thank you so much, and see you in the next video.